All around us, there's this invisible conversation happening pretty much constantly. It's like a hidden language that our tech uses to turn the physical world into digital information, and then turn that information back into real, tangible stuff. So today, we're going to pull back the curtain and make that hidden language visible.
I mean, it starts with something we've all experienced, right? You're at a restaurant, you see one of those weird blocky squares on a poster, you point your phone at it, and boom, the menu just pops up. But how? I mean, what is actually going on in that split second?
Well, it's definitely not magic. It's a language, a constant back and forth of input and output. And in this explainer, that's exactly what we're going to do. We're going to decode that language. We'll start with the simplest symbols and work our way all the way up to systems that can see, create, and even react to the world all on their own. All right, Section 1, From Lines to Links. Let's kick things off with the simple codes that quietly run so much of our world, starting with, a true icon of the modern checkout line. Ah, the humble barcode. We see them so often we barely even notice them anymore. But these simple parallel lines, they're basically a super compact language. A scanner just reads that pattern of light and dark lines to instantly pull a product's info from a huge database. It's so simple, but it was absolutely revolutionary.
And the impact? It's just massive. For businesses, it means way faster inventory counts and a goldmine of data on what's selling. And for us, the customers, well, we get quicker checkouts, way fewer pricing mistakes, and those nice itemized receipts. It's a total masterclass in efficiency.
Okay, but what happens when you need to store more data than a barcode can handle? Well, that's where the QR code comes in. Instead of just one dimension of lines, it uses a whole two-dimensional grid of squares. And that matrix structure means it can hold way more complex info, like a full website address or even your Wi-Fi password.
So when you point your phone at one of these, you're kicking off this incredibly fast process. First, your camera grabs a picture of the code. Then, the software on your phone analyzes that pattern of squares. It converts that pattern into usable data, like a web link. And finally, your device just does what it's told, like opening that website. It's like a perfect four-step digital handshake that happens in a blink.
Okay, Section 2, Capturing the Real World. So, reading codes is one thing, but what about capturing the world as it actually is? Now we're going to move from flat images to full dimensions.
I'm sure we've all done this. You're at the airport, you place your passport on that glass screen, a bright light flashes underneath, and suddenly all your info is right there on the monitor. That's a 2D scanner doing its job, turning a physical document into digital data, making the whole security process faster and a lot more accurate.
But flat surfaces are, well, flat. And the world isn't flat, is it? To digitize a real object, with its curves, its depth, all its texture, we've got to level up. We need to add that all-important third dimension.
And that brings us to the 3D scanner. Now, this device doesn't just take a picture. No, it analyzes an object's precise geometry to create a complete digital blueprint, a 3D model. And maybe one of the most powerful and familiar examples of this tech is something that saves lives every single day, the CT scanner.
A CT scanner is basically a highly specialized medical 3D scanner. It takes a whole series of X-ray slices of a part of your body. Then, a computer digitally stacks all those slices together to build a complete 3D model. And this is the real magic right here. It lets doctors see organs, bones, and tissue in incredible detail, all without ever having to make a single cut. All right, Section 3, Painting with Light. So we've talked a lot about getting information into our devices. But what about getting it out? How does all that digital data become the light and color that we actually see on a screen? Well, for big screens like projectors, you've basically got two main technologies battling it out. On one side, you have LCD projectors. They work by shining a really powerful light through three separate panels, one for red, one for green, and one for blue. They're famous for really sharp images and great color. On the other side, you've got DLP projectors. These use a chip covered in millions of microscopic tilting mirrors to reflect light. They're praised for super smooth video and really high contrast. So two totally different approaches, but they have the exact same goal, turning data into a visible image. Okay, now let's talk about the screens we hold in our hands every day. The classic LCD screen, the kind with an LED backlight.
works by shining that light source through a layer of liquid crystals and color filters. It's proven, cost-effective tech. But then you've got OLED, and this is where the game completely changes. The key difference is this. With an OLED screen, every single tiny pixel produces its own light. There's no separate backlight at all.
And getting rid of that backlight, it changes everything. Suddenly, screens can be thinner, lighter, and even flexible. And because each pixel can turn completely off, you get perfect inky blacks. That creates what we call infinite contrast and absolutely stunning colors. On top of all that, they have faster response times for smoother motion, and they're more energy efficient, which is exactly why OLED has become the gold standard for pretty much all high-end devices. Okay, Section 4, Printing the Impossible. So far, we've captured the world as data, and we've displayed that data as light. Now for the final mind-bending leap, turning digital information back into a solid physical object. Welcome to the world of 3D printing. So how on earth do you print a solid object? Well, it all starts with a digital blueprint, a 3D model. Special software takes that model and digitally slices it into thousands of incredibly thin layers. The printer then reads that file and gets to work, building the object from the ground up. It deposits the material layer by tiny layer, fusing each new layer to the one below it, until slowly a solid physical object emerges from what was just a digital design.
And believe me, this isn't science fiction anymore. This technology is fundamentally changing entire industries. We're talking about things like custom-fit prosthetic limbs that perfectly match a person's body, incredibly detailed anatomical models that surgeons can use for practice before a complex operation, and rapid prototypes that let engineers test a new part in hours instead of weeks. 3D printing is truly closing the gap between a digital idea and a physical reality.
And now, Section 5, the world that responds. So let's recap. We have devices that can see the world, that's our input, and we have devices that can affect the world, that's our output. The real magic, though, the truly incredible stuff, happens when you put those two things together.
The core idea here is actually beautifully simple. You just pair a sensor, that's the input device that monitors something, with what's called an actuator, that's the output device that does something. You link those two with a bit of computer logic, and just like that, you've created a system where the digital world can actively control the physical world.
Just take a look at these two examples. In a hospital, you've got sensors monitoring a patient's vital signs. If their heart rate, the input, drops dangerously low, the output is an alarm that immediately alerts the medical staff. Or think about a high-tech greenhouse. Sensors monitor the temperature. If it gets too cold, the output is a heater automatically turning on. It's the exact same logic loop: input, process, output.
And once you start to recognize that pattern, you realize it's everywhere. Your thermostat at home? That's a simple control system. That motion-detecting security light outside a building? That's another one. These systems are like the invisible engines of our modern world, constantly monitoring and reacting to keep everything around us stable, safe, and efficient.
So we've gone on quite a journey here, from simple lines on a box all the way to complex systems that can literally see, build, and respond to the world around them. This ongoing conversation between our physical and digital worlds is only going to get more sophisticated. And that leaves us with a really important final question to think about. As these devices get smarter, faster, and more autonomous, how do we make sure that they're always working for us?